Welcome back, student. Thank you for joining this lecture, and I hope you are enjoying until now. So, to this lecture, after measuring the detecting the bias or knowing the fairness, mitigation, and building the inclusive system design, now the question arises that what we are talking about fairness, right? What does this fairness mean actually in AI? So, fairness could mean equal treatment, equal opportunity, equal outcome. Now, we can think of equal treatment, equal opportunity, equal outcome, but these are not always the same thing for all the time. So, everyone say AI should be fair. Now, we just saw that we do not have single fairness detection method or single fairness removal strategy. But fairness, that is why the fairness is not a single universal idea. What seems fair for one community may not be fair for another community. Like there are different countries are there, and different country have different way of working, they have different constitution or principle of governing the country. If we apply my country ethical principle or what is right and not right from our country to another country, which is not right thing, because if that was right, then every country would have been following the UN Charter, which is a one constitution. But every country have their own constitution and they have own way of meaning. So, that means also that fairness is not a universal idea. In practice, fairness can mean different thing, and those meanings can conflict. Even in our own individually, a different kind of fairness can mean different things. So, let us see in this lecture what are the different definition of fairness in AI and the concept of it. So, simple question that becomes surprisingly difficult, it is a simple question, fairness, but it's often is more difficult. Suppose an AI hiring system, it applies the same rules to everyone. Is it fair? You tell me. I give you an example that a hiring system, Norway does not have that much inequality, but let us say some country which has higher income disparity, like I come from India, right. Now, I come from India, there the education at different places are not having same type of teachers, same type of education, although by government the board exam syllabus is same, but you are not going to give a board exam, you learn throughout your education journey. So, the school teaching methodologies are not same, the teachers are not equally equipped. So, typically it has been seen that urban area the students are having much more resources, in the rural area they have less resources. Often one teacher is conducting lectures for 5 different classes together, like standard 1, standard 2, standard 3, standard 4, standard 5, one time the person is taking. So, as people coming from that kind of place often not getting the same standard of education like the urban places. Similarly, the people who are economically rich, they have access to good books, they have access to computer, they have access to helping, they have access to better school and better teaching methodology. The people who are poor or less economically, they may not even have access to pencil or pen or papers. So, they are having lot of hindrance in their learning things. So, if we are expecting that, okay, I will judge this ultra super rich elite class and poor and coming from rural who does not have same kind of equity system, same kind of system available, can we judge them same? Forget about this economic disparity. Let us say people with disability. a person who is fully functional like me, 2 hands, 2 legs, I can run, I can think. Now if I have a person who has vision impairedness, or let us say 20% only the person can see, and if you say that okay, you should be treated equally because you are human, it is not fair, because this person who has to work too hard to get a certain kind of grade or certain kind of education compared to the person who is from elite class, have all the resources and all the good and everything into the plate. So same rules if you apply to everyone, that can you can say that equal, but we also need to take into account this kind of thing into the system. Now selecting different percentage across groups is more accurate for one group or than the other. Now question is here, that is that fair if we build this kind of system, but often it is not. At first fairness does sound simple, but once AI make real decision, we have to ask fair in what sense. What you will learn today in this lecture is what fairness in AI means, the major way fairness is defined, since we have a different meaning of fairness, but we will be covering major way fairness can be defined and why different fairness concept can conflict. So by now you will know that the biasness, there are different types of biasness, there is no universal biasness. Now bias detection also, there is no universal bias detection method, there is no universal bias mitigation method. Now we also coming to know that there is no universal fairness estimation method. So different fairness concepts are there and they can often conflict with each other. Now how context changes and what fairness should mean when the context changes. So what is a fairness in AI? Fairness in AI means that we are designing a system that treat people and group equitably, and we should be avoid unjust and discriminatory outcomes. The group for which AI system is developed should not be giving discriminatory outcome or injustice behavior or inferencing, and it should not include historical biases. It should not reinforce harmful historical biases, means historical bias is there, but harmful historical bias it should not include. So fairness is about more than technical correction. It is about whether AI decisions are justifiable, equitable, and also socially responsible. So fairness is not one idea, it is a family of ideas. Means there are no one definition of fairness, so we should look into the fairness aspect as a family of ideas or families of definition. So fairness can mean same treatment, it can also mean same outcome, it can also mean same opportunity, it can also mean same reliability, and it can also mean consistency across individual. Now fairness is not one thing. I just give you example from Indian Constitution. If fairness is one mean, that then Indian Constitution will not need to include the fairness 6 article. To include the fairness into our Indian society, the Constitution required 6 article. If it was so simple, one word or one sentence, it could have been easily possible, but since it is very complex, fairness, same treatment means something else, same outcome means something else, same opportunity means something else, same reliability means something else, consistency across individuals means something else, and there can be many fairness criteria. So that is why fairness is difficult. People may all support fairness, we all say that we want a fair system, but we often disagree about what fairness should require. So this is common behavior across the globe and across the nation, across the society. So we again come back to our same AI based loan approval system. Now, when AI system is used to approve or reject loan, we want to know whether it is fair across different groups. Now, question comes, does it treat everyone the same? Should it, or does it? Does it approve groups at the same rate? We have different groups of people applying for loan. Is it treating different groups at the same approval rate or same rejection rate? Does it identify qualified applicant equally well? So, same rate, does it identify qualified applicant equally well? So, let us give a scenario. Let us say a group 2 is there. Let I assume that they are from the darker skin black society, and whatever applicant, they all have very good document and criteria, they have good credit rating, and logically if human judge it, they should all be qualifying it. Now, if we start making a rejection or approval across same rate, now if I have 100 applicant and all qualifying, in the name of equal error rate, why should I reject some? If 100 are very well qualified, we should approve it. Are its decision equally trustworthy? Means, can we trust this decision making? So, there are major type of fairness in AI, like group fairness, which ensure different demographic groups are treated equally. Example, equal loan or approval rate across different races. Individual fairness, similar individuals should receive similar kind of outcome, two equally qualified applicant treated the same way. Demographic parity, positive outcomes are distributed equally across groups, that means same hiring rate for men and women. Equal opportunity, equal true positive rate across groups, that means same chances of being correctly selected. Fairness through awareness, that means use sensitive attribute to ensure fair treatment. So, if the historical data has some disadvantages, we can be adjusting for those disadvantages. So, these categories help us think about whether fairness is about groups, individuals, processes or outcomes. Let us go them with some example. Group fairness. On system, it looks fair, important groups are treated comparably. Examples, similar approval rate, similar error rate, similar opportunity across groups. So, group fairness is especially important when we are concerned about historical disadvantages, because in history, in past, let us say USA, certain especially the black people were not allowed to study, and later on they were not allowed to vote, and later on women from black society were not allowed to vote, and finally everyone got the equal treatment by 60s, which is quite surprising. Now, historically data is skewed. If we use the historical data, then they will be still be under disadvantage. So, we should think about historical disadvantages or protected attributes such as gender, race, disability or age. Individual fairness, a system is fair if similar individuals are treated similarly. So, if two individuals of same quality, same application, same income strata and same credit score should be treated similarly. So, if two applicants are qualified, equally qualified, should they receive the same decision? Now, if it happens that there are only one job position, so but then two candidates got exactly equal rating for the hiring process, then what to do? So, if both are getting the same rating, then ideally they should be given the job, but if one is having higher rating, other has slightly lower rating, then the one who is getting the higher rating should be given a job, because there is only one job is there. So, idea focus less on groups for individual fairness and more on consistency between comparable individuals. So, equal treatment is not always equal outcome. So, means if you are treating someone equal, that does not mean that we are giving equal outcome. Same rules for everyone for equal treatment or same results across group is a equal outcome. So, for equal treatment we are applying same rules, for equal outcome you are applying similar results for across the group. So, system may apply same rule to everyone and still produce unequal outcomes if society itself is unequal. What does it mean? That we said that same rules for everyone. Now, if I posted a job, let us say I posted 2 jobs, and in my demography I have 2 group of people in a demography. Now, if the number of people applied for the job, I have 2 jobs, 100 people applied for the job. Now, if 99 people applied from one group for the 2 job and 1 person only applied from the another group for the 2 job. Now, if we go by equal treatment, we apply same rules for everyone. Now, if you go by equal outcome, that means we have 2 job, we have 2 group, we have to give job to each of the group, 1 job to each. Now, if we have not declared in the job post that job will be given to 2 groups, if we have said that we will be treating people equally, now to enforce equal outcome, that means 1 job to each group, we and the one who is only 1 person representing 1 group and the person did not perform well or does not qualify for the job, if we go for equal outcome we have to offer job to this group, the one who is still not qualified, and the group where 99 people applied and we are only offering 1 job to the one who is the best, even the second best is much better than the person from the other group, then by enforcing equal outcome we can make society itself unequal, because here the applicants are already unequal. Now, equal opportunity as a fairness. If we say that system should give a similarly qualified individual under similar chances, for example, loan example, if applicants are equally credit rating, they should equally be likely to be approved. So, this equal opportunity as a fairness focuses not on outcome alone, but on whether deserving cases are recognized equally. Now, this fairness is quite large topic and different taxonomy of AI fairness is there. So, if you go by fairness, there are group fairness, within the group fairness we have conditional similarity, we have demographic parity, in the individual fairness we have fairness by awareness, then we have fairness by unawareness, then sampling metric, the fairness by sufficiency metric, then we have fairness by causal based, then fairness by other techniques. So, you can see 1, 2, 3, 4, 9, 12, 15, 14 and 5, 19. There are 19 different kind of taxonomies are there for AI fairness. There could be more. I am not saying this is exhaustive, this is what I am putting it from the book. So, taxonomy help us organize many meanings of fairness, but the key point is that are these meanings are related. Here we can see that these meanings are related, some of the fairness, but not identical. So, different definition of fairness can disagree, that is why, because they are not identical, they have been coined for measuring a different types of fairness. A system may have equal error approval rate, but unequal true positive rate, or equal accuracy, but unequal reliability across group. Now, question comes, which kind of fairness matters most? That is a central challenge in AI fairness, that a system may satisfy one fairness idea while failing the another. It's quite a dilemma for AI developer, the people who are building the AI system. So, this design or this deciding that what kind of fairness we will be ensuring, that should be done during the system design phase, and by targeting the problem statement or for the group of people we are building the system, and also knowing what is the primary requirement which we must satisfy for building that system. So, what fairness measures are really trying to capture means we saw 19 types of fairness in the previous slide. What they are typically trying to capture is, are outcomes distributed similarly? Are opportunities distributed similarly? Are errors, if the system is doing errors, is this error happening similarly across, or are prediction equally reliable? Means if a prediction for one class we can rely, can we also rely similar scale for prediction for second class? So, mathematics does matter, but first we must understand what question of fairness measure is answering. Means we have the maths for measuring fairness, but we should first understand what really the fairness is measuring, or the math is there, but what is truly measuring. Example, fairness as equal outcomes. So, if we say that fairness as equal outcomes, so here the question we are trying to answer, that do different group receive positive decision at similar rate. That means, if we have two group, an AI system is for two group, if a positive is given for one group and positive decision is given for one group, positive is given for second group, is both the group receive the positive decision at similar rate. That means, for loan example of our system, are loans approved at similar rate across the groups the loan system has been built for. So, this view of emphasizes that distribution of benefit, not just same rule everywhere. Then comes fairness as equal error burden. Now, here what we are trying to address is that, are false positive or false negative concentrated in one group. I was giving you previous example that we have 100 applicant and 99 from one group, 1 from another group. So, false positive, if we say for this 99 from one group, or we have accuracy of 100% for one group and 100% for other group. Now, if you estimate the accuracy, total accuracy, it is going to be 99%. So, here what we will see that false positive and false negative are not are actually concentrated in one group. So, in many domains, fairness is not only about who receive the benefit, it is also about who bear the cost of mistake. So, in this example where one group is always getting 100% accurate and the other group is always getting 100% inaccurate. So, the cost of mistake the other group is bearing, while the cost of mistake the another group is not bearing. So, the fairness as equal error burden measuring that. Then comes the fairness as equal reliability. So, now when we model predict something positive, is that prediction equally trustworthy? Means model say yes, but this yes prediction, is it trustworthy across all the group? Like in the previous example, when model is saying 100% for one group and while the another group 100% negative, although it was positive. So, can we trust that model? So, this particular fairness matter, because a model may produce the same number of positive decisions across group, yet those decisions are not equally reliable. Means for one group the decisions are reliable, but for other group decision may not be reliable. Now, here this brings to the question that why protected attributes matter. So, typically in the biasness getting introduced because of various reasons because of gender, race or ethnicity. These attributes are there into the data set: disability, age, language or accent, socioeconomic background. So, fairness discussion often focus on characteristic, but have historically shaped unequal treatment or exclusion. So, fairness depend also on context. Different domain may prioritize different fairness idea. So, the system you are building for the domain, they have a different criteria. For example, if you are building an hiring based AI system, hiring equal opportunity is prioritized as a fairness more there. Now, if you are building an AI system for loan approval, then equal outcome and transparency is prioritized more there. Now, if you are building an healthcare AI system, then equal recognition of true need must be prioritized more there. Now, if you have an AI system for criminal justice, then error burden may matter more deeply, means which group mistakes are bearing the burnt of the mistake, that is much more matter. So, there is no single fairness definition, that is why, because that fits every application, different kind of fairness principle or requirements are there. So, context definitely matters a lot. That brings to the thing that same system can look fair or unfair depending on the definition. The AI based loan approver, equal approval rate, but lower success detection for one group and slightly different reliability. Now, the question comes, is the system fair? It depends on how we are defining fairness for this application. Now, there are different kind of fairness measures are there, like equalize odd. Now, equalize odd for loan approval, group A applicants are majority population and group B are minority population. Now, model prediction, what it did, that actual repairs from group A are 50 and actual repair for group B are 50, but predicted approved rate for group A is 40 and group B is 40. So, true positive rate is 80%, 80%. Now, here everything is there. So, the true positive rate for both group is 80% and false positive for both group is 20%. So, this is with the equalized odd, right. Now, for equal opportunity, whether it is for binary classification. Now, group A has 100 qualified student, group B has 100 qualified student, but prediction did 180 and 2 positive. Now, if that is for equal opportunity, if the model is equal opportunity adhering. Now, if bias exists. So, in a bias system, what can happen that for group A, the same 100 qualified candidate, it is predicting 80% true positive, while for group B, it is predicting 60 true positive. So, true positive rate are not equal. Well, for one group, it is 80% and for other it is 60%. So, here equal opportunity measure has been violated. So, group B qualified candidates are less likely to be recognized by the model, and that's lead to the unfair disadvantages. Now, balance for negative class. Sometimes, like example said, one group has majority population while other group has minority population. Now, for each group has 100 application and 50 will repay and 50 will default from this group. Now, if it is a balanced prediction outcome, then that will have everything equal. But now, if the model is biased towards the negative class, then for one group it is going to be predict approval rate 10 for while other predict approval rate 20. So, the positive rate is 20% in one group while 40% in another group. So, here the equal opportunity rate and equalized odds are due to unequal false positive rate is there. Now, if we focus on balance for positive class. So, in that case also if you see if the bias exists, then for one class it is predicted 48, the other class it is predicted 36. So, for one true positive rate is 80%, for the other true positive rate is 60%. So, here equal opportunity has been violated if we balancing the positive class. Now, the hard part of fairness is not only measurement, it is a value choice. Means if you want to put a fairness, measurement is not the only way. So, fairness decision requires what should be equalized and which harm matters the most. Means model is going to do error, what harm is going to be, we should be addressing the most, which group need protection and what trade-offs are acceptable between accuracy and other parameter. So, this leads to the question that why AI fairness is both technical and a moral question. So, moral question is quite play a role here. So, the key takeaway from this lecture is that fairness in AI is a multidimensional concept. It is not one dimension. Fairness has many definitions and many ways we can measure fairness for different domain, different condition. The different kind of fairness measure is going to be useful. Different definition of fairness capture different priorities. So, we need to know that the AI system we are developing, which priorities are going to be more important, and that will help us choosing the fairness criteria better. Now, fairness idea can conflict with one another because different fairness criteria measuring different thing. So, one can conflict the other. Now, right fairness concept depend how to choose a right fairness concept. It depends on the context, value, and harm is done to what level and what harm we can tolerate or need to address. So, with this the next lecture is going to be on policy, legal and regulatory framework for fair AI, and I hope you understood or enjoyed the topic. There are more things are there in the book like demographic parity, then statistical parity, fairness through awareness, then fairness through unawareness, and like fairness through unawareness is example resume screening, and see you in the next class. I hope you enjoyed this lecture.